All right, we're recording. All right. Has anybody heard of the call stack before? Or it's called like the call stack, the execution stack. There's a few names for it. If anybody want to give me, it's for me, it's kind of difficult. It was initially difficult to like conceptualize visually. So it's okay if you don't 100% understand it, but this will make more sense when we get into recursion. Can anybody kind of give me a quick TLDR of what the call stack is, if possible?
Is it like a place in memory that the computer designates for results to come in a function? So it like sets like a block of memory aside, stores information, waiting for an answer as a function executes?
I actually don't know if yeah, I mean, actually, I actually don't know if it's that specific. Does anybody can
Sounds
clarify?
about right.
Yeah.
I mean, you call a function, and then from within that function, you call another function. Well, it puts that function on the call stack while it goes and does the next function, even if that next function is itself. And that whole execution context is stored on the stack. So it's calling more and more functions. So now you pile more stuff on the stack. And then once those functions complete, it starts popping off the top of the stack in reverse order, which is also how you kind of conceptualize recursion, because you're just doing the same thing only with the same function.
Right. No, yeah.
Another way to picture it would be old school call waiting. So you're talking to somebody on the phone, and then somebody else calls you. You put the first person on hold to answer the second person, but you have no way of choosing who to go back to. So let's say you're talking to 5 people. You can't just say, I want to go talk to the first person directly. When you hang up with the last person, now you're back on number 4. You talk with, so it's kind of old school call waiting.
And the call stack, I know Noah mentioned it yesterday, the stack is like a data structure. It only operates in a certain way. And when you think of I think of like a pack or a stack of pancakes. When you first make a pancake, you put it on the plate, and you make another pancake, you put that pancake on it, then you make another pancake, and it just keeps on piling up. So now you have a stack of pancakes. And when you go to take off a pancake, you take it off from the top, and then the next one is the very top one. So it's the whole LIFO, last in, first out. So the call stack, a stack is a type of data structure. The call stack stores executions of code on the stack in the order they are executed and removes them from the stack when they are done executing. So this happens when you have a function that calls another function, as Justin said, that calls another function. So function calls another function, and this function calls another function, and this function calls another function, and it just keeps stacking up. So let's go through like a quick visualization, and we'll actually run through code and show you kind of like what the call stack in action. So here's a call stack visualization. We have this main function that console logs main starting. Then it calls the second function that's literally called second. That takes in a number 1, number 2. We don't really do anything with those inputs. So inside the second function, we console log second starting. Then inside the second function, we call the third function, which is down here, which console logs third starting. And then once third returns, comes up here. So third returns, third removed from the call stack, and then second removed from the call stack, then main removed from the call stack. And we start executing that down here where we actually invoke the main function. So if I go through, down here, we invoke the main function. So the main function is running up here. The next thing that's going to be popped on the stack is that console log main starting. Again, console log, the log is literally just a function that prints something out to the screen. So console log executes. What should we see next? Like what should happen with the stack right after this?
Second starting?
Well, the console.log essentially executes and then stops executing. So
In the pop console log off the stack.
yep, console.log gets popped off the stack. Now we have the second starting. And now what should we see? The second starting console log. And that console log gets popped off the stack. And now that's down right here. Now we call the third function. Now throughout this time, the main function is still executing. It's still running. So is second. Second is still running. And third just started running. Because we get the console.log third starting. Then we pop that one off the stack. Now what should happen after we pop the console log third starting? So console log third starting just got popped off the stack. Now we actually return third. So that one is done executing. And once third is done executing, the second gets removed from the call stack. And then finally the main gets removed from the call stack. So that's like a call stack visualization. That's why it's called the call stacks or execution stack. It's just a stack of code in the order in which it's executed. All right. Does anybody have any questions about that? Let's see if we can cd code. OP recursion. So this is essentially just what I just had. Where is it? Yep. So this is kind of just exactly what I kind of just had on the screen, the previous slide. Let's see. I want to see something. I'm going to close this. Hold on a second. Bear with me. Oh, crap. All right. 1 second. All right. So here we had what we just kind of had over there. I'm going to add some breakpoints. So what I'm doing right now in VS Code is adding breakpoints. I think this should work. In here, so VS Code has this really cool debugger thing. We can actually debug some stuff. So if I run this, let's see if this works. So I'm running some debugging. We have this thing called the call stack. Let's see this thing in action. Let's see if it actually works. So we have the main JS gets called. We have the second get called right here. And down here, you can see in the console main starting. Third gets called. And now it's going to next it's going to execute that console.log. Third starting. And then we're going to return 3. So the 3 got taken off the stack. Next, the second gets taken off the stack. And finally, the main method or the main function gets called off the stack. Does anybody have any questions about the call stack? You can do another one. So this is all in JavaScript right now. It's same thing as far as Python. So here I'm in the browser. Browser has a call stack. Over here, I'm in sources. Don't necessarily worry about the specific Chrome Dev Tools. I just want to see the call stack. So in here, I've got this code, same code that we've been writing. I want to refresh this. And now I'm entering debugger. Just watch this call stack here. So it's coming down here, has yet to call main. If I click the next step, main is called. And now notice down here in the console, it should console log main starting next. Bam, main starting. Next, it should call the second. Second has yet to be called and it's not on the stack yet. Second just got called, now it's put on the stack. Now it's down here in this console log. Second starting. Next is going to be third. Should be placed on the stack. Third is on the stack. Third should be starting next. Third starting. Now third is on the stack. We're going to return third. So the third function is going to be done executing. So it should be popped off the stack. It's because it's got a console log first. Console log. So yeah, the third, never mind, I didn't get it. So third got popped off the stack. Now it's about to execute that return the string. Now second's going to be popped off the stack. And then finally, it's going to return the main from the call stack. And there. Now the main has gotten. Now why this is important as far as when it comes to recursion. Let's go into, so that's the call stack. Now let's talk about recursion. CD. What is recursion? I know some of you have kind of already kind of been exposed to it.
It's a function that calls itself n minus 1 times.
Function that essentially just calls itself. Depending on the requirements of the function, it can be one, it can subtract stuff. Make directory recursion. Let's do JS. Touch recursion.js, cd recursion, or list code recursion.js. So there's essentially two, so recursion is a function that calls itself. There's two things that you need to do when it comes to creating a recursive function. What are the two things you need? Does anybody know?
You need a base case and a way to make the problem smaller.
A base case and a way to make the problem smaller. Can you expand on that?
So from my understanding, recursion is just a way to break a problem down into smaller and smaller steps until you reach a base case.
Okay. So yeah, so you need a base case. What is the base case?
Base case is similar as far as recursion and while loops. A base case would be similar to the condition statement in the while loop. You know, it's the point where we're no longer going to execute or go further, would be the base case. And then the other part that he mentioned, I guess the reduction in the problem, that would be similar to the incrementing or decrementing, you know, changing your value that you're testing in your condition.
Yep. So the base case is when the function stops calling itself. when should the function stop calling itself? And then there's the recursive case of when the function actually calls itself. When should the function call itself? So when you're writing a recursive case, make sure you have a base case. So just ask yourself, when should this function stop calling itself? Otherwise, you should essentially jumping into the recursive case is then the function should call itself. But now you have to kind of determine like what needs to be passed into the parameter as a parameter when you call itself. So let's just do a quick one. Let's do it iteratively. And then let's do this recursively. So let's do const space x countdown. So if you've ever watched like the SpaceX launches, they're pretty cool. So SpaceX countdown takes in a number and it's going to count down from like 10 down to 1, and then it should say liftoff. So if I want to do this iteratively, I can just do a for loop. So let I equals num, I is greater than 0, and I minus minus, and I can console log I, because I want to print down 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then once it's greater than 0, so once it hits 0, it breaks out of this for loop and it returns console log liftoff. So if I wanted to run this, clear node recursion.js. Oh, I actually have to invoke it. So SpaceX countdown, pass in 10, clear. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, liftoff. Now, if I want to do this recursively, just remember the two steps, base case and recursive case. I'm going to comment this out. Const SpaceX countdown. Pretty much everything's the same. So base case. What should be the base case of the countdown?
It'll be the exact same portion as your middle on the for loop. So I is greater than 0 if you're keeping track of any type of parameter that you're going to pass into it. So num in this case, num is greater than 0.
So I can say if num is greater than 0.
Well, it's probably once num equals 1,
Okay.
right?
I can do once if num equals 0. Yep, you're right. I'm going to do if num equals 0, console log liftoff. So once number equals 0, this is my base case. Else, I can do an else statement, or I don't necessarily need one. Else, I can console log the number, and then I need to return the SpaceX countdown again. Oh, not that. So if my initial value is 10, comes in here, 10 is input in here. If number equals 0, do console log liftoff. Else, print 10. But then I want to return SpaceX countdown, but instead of with the initial parameter of 10 put in there, what do I want to put in here?
Num minus 1. It's your
Num
decrement.
minus 1. So initially it's 10, comes in here. If num equals 0, do liftoff, else return 10 minus 1, which is 9. So it comes back up here, 9. If 9 equals 0, console log liftoff, else console log 9, return 9 minus 1 equals 8, comes up here, 8. Is 8 equals 0? No. So it comes down here, console logs 8, and then returns SpaceX countdown. 8 passed in minus 1 is 7, 6, 5, 4, 3, 2, 1 until it reaches 0. So when num minus, so once it gets down to 1, SpaceX countdown 1 minus 1 equals 0. So 0 gets passed up here. If num minus, or if num equals 0, I'm going to do return console log liftoff. So let's see what this looks like. Same thing. Now, why do I bring up the call stack this whole time? It's because when I first invoke SpaceX countdown, the first time, it's running consistently. Let's see if I can. Where'd it go? So essentially, recursive count or SpaceX countdown is called once at 10. It's called again once it's at 9, 8, 7, 6, 5, 4, 3, 2, 1. So it's going to continue calling it until my base case is hit. And then it's just going to keep on returning and popping off the stack. So I want to show you. And now what if I didn't have this base case? What if I had like, what if I messed it up and it was like, well, number is greater than 10? What's going to happen if I call it and I get my base case wrong?
Infinite loops.
Bam.
Won't execute or
Says maximum call stack size exceeded. So it just kept on it kept on executing the SpaceX countdown until the call stack, essentially there was no more memory left. And it's like, oh yeah, we can't execute anymore. We can't store any more code or operations in memory. So it's like maximum call stack exceeded and it's going to break. Let's look at this. Oh, man. Does anybody have any question about this part of recursion? You can even see it in the in this call stack. Let's see if it works.
So Tom, I'm assuming the point here is you put OSABEN functions, SpaceX countdown functions in the call stack, and if I would have used the decrement and counter, I would have had what, just one thing in the call stack? Is that what we're getting at here?
Yep, correct. So if I just did this one, I'd only have one function on the call stack. But since I'm using recursion, I'm calling itself. So it's putting itself, like the countdown SpaceX, 10 times on the call stack until that base case is hit. And then it's like sort of collapses. It all comes off at the very end. I want to see if this works real quick. SpaceX countdown. So I called it once. If I keep on calling it, it's just going to keep on stacking the SpaceX countdown on the stack until liftoff is hit, and then it all like pretty much is done executing. Let's do some more. or SpaceX countdown. If I wanted to, like, if I had an array, or if I wanted to add all the elements in an array, I can have an array and then the total. And what's my base case if I wanted to add all the elements in an array of integers up? I can do, like, I'm going to do, my base case is if array.length, I can do array.length. So if the array.length, there is no array.length, then I can just console log the answer. And I'm going to have to probably return the answer at some point. So I need let answer. So I'm thinking I've got this array of integers. I want to grab the first element in the integer or in that array. Array.shift. I'm sorry. So, and then I want to add everything up. So let answer equals total plus first. So my base case is when array length doesn't exist, or there isn't an array length, else return first plus add array answer. I want to see what this looks like. So recursive. So I'm actually manipulating the array. With this array.shift. So if I have an array called let array equals 1, 2, 3, 4, 5, and I add array, and then the initial total is 0, or the initial answer is 0. I'm going to run this. Terminal, clear, 15. So 4, 9, 12, 15. So it comes in here, shifts the first element off the array. That's 1. Answer plus total. So total initially is 0 plus 1. The answer is 1. And the array is 1 length shorter. So now it's like 2, 3, 4. So the array still has a length. So it skips the base case, and comes in here. 1 plus add array answer. If I just wanted to add values up to a specific number. So recursion, add up to, so I can let add up to equals some number that I want to add every element or every thing up to. It's an if num equals 1, I can return return 1. So this is the base case. If number equals 1, else return number plus add up to num minus 1. So we're going to add up to Let's do 10. Oh. What's going on? Why isn't it working?
Should in 48 should it be return the number, not returning 1?
Oh, yeah, let's see. No, it's still going to print 1. Add up to, so if 10. Oh, I think I still need a.
There's no loop there.
Yeah.
You're going from 1 to 10.
One. I'm not adding. So the first number is 10. And then, so for example, if num is initial input is 10, comes into here, 10 plus the value of this, so 10 minus 1 is 9. So it'd be literally like num 10 plus 9 comes in here. 9 is 9 equal to 1? Nope. 9 plus 8 plus 7. So it is working. We're just not printing out anything. So I could print out like that. And it's going to be like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So it actually is returning the value it's actually returning all these values added up to one another. It's just we're not printing it out anywhere. So we're saying 10 plus 9 plus 8 plus 7 plus 6 plus 5. With that, so let's do a quick factorial, one of your challenges last week. So let factorial equals number. We're going to define the base case real quick. With factorials doing like 4 times 3 times 2 times 1. Is that correct? Oh, I could have just done this. Sorry. So if I printed it, it should work.
Console.log.
Thank you. Don't want to print my node.
Yeah, your add up to, I think, instead of returning 1, you wanted to return num.
Return.
Yeah, return or console log num.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So well, we can do something easy. 3. So add up to 3. So 3 plus 2 plus 1 equals 6. So I'm just console logging. So if we do factorial, our base case is pretty much the same thing as this one, add up to. Base case, if num equals 1, you just want to return 1. Else, recursive case, else do return factorial num minus 1. So if num
Tom,
equals,
quick question.
yep,
The triple equals check faster than the double equals because it doesn't have to do a type check.
I mean, logically that makes sense, but in the grand scheme of things, it's minute, and
Okay.
it's better to test the triple equals just so you know and for a fact that it's in fact by type as well.
Okay, thanks.
Else return num times factorial num minus 1. So if we run that, console.log factorial for, what is it? Comment this out. 24. So 4 times 3 times 2. So with that,